Live stream, so it's actually live streaming, but
Good one.
but I don't really know how to copy the address. I'm thinking of copy the address so like to post so other people could see.
What do you mean? What do you mean? Like, what do you mean?
This must have an address, right? Like
Yeah.
YouTube, whatever the thing is.
Yeah. So what is the account that it's on?
It's this account. So it's specially made for this meetup.
How did you get it to? Can you do a search for it? Can you show us what it was again? Oh, ALIN. ALIN. Robotics. So I was correct. It says there ALIN down the bottom there. So
I think there's somewhere I could copy the address and
if I find that account, it'll then come up. Okay, just type it in. I know what it is. Correct.
so this is one section. Sometimes you have to start on other type. Next, maybe the next session. At some of the session at episode. Are you guys interested?
Did you find it?
So is it working?
Yeah, that's her address for that setup as opposed to Yeah, I know how to find it.
There is
You should be able to search it, but maybe can you click on a new tab and then open up YouTube and then do a search in there for it?
I think there's somewhere says the address.
Yeah.
I saw the address somewhere, but not really sure it's.
You should find it.
Should be able to see the address of this thing and send it to some. How much do you guys wanna?
I think I still would rather do it within a web browser and then see if you can actually search for it.
It's live.
Okay. Sorry about the delays. We'll throw the price to work in progress. But my idea was, started on this couple of months back, robots are really
I will post it in the meetup so you guys can.
so okay, well, then I start building a robot. One idea, this robot is not, there's no artificial intelligence, it's just a simple remote presence robot. This connects to the internet, I can put it anywhere in the world. My interface here, so that's more or less just like a Zoom Skype with a meeting, move this thing around, the camera, microphone, loudspeakers, right behind the remote presence. It's not rocket science. There are millions of other things like that around, but okay, I'll just do it. Yeah. Okay, instead this interface here, it's all very go to flight connected to the Xbox controller. First, I have these buttons that you press on the website. Move it around, but you can connect the Xbox controller and then here, this is you can see depending on the bandwidth and you can see what the robot is doing, then I can move the camera around. Because it's not a good connection, it's a bit grainy. The camera there. Plus, can I go to feature? Fine. There we go. For example, this is working something. This is the moment I could walk up there and get to the dawn. See that at the table. There. And I can, because it's too close here, then there's feedback. Hello. So you want to go on and off. Lots of challenges, there's mechanical things you have to solve. I'm talking to the motors down there. It was very bumpy in the beginning. First, I had 3 legs down there, and I had one chair leg at the end. It was too bumpy, so another one with 4 legs now. And also, if you look at the way our buildings, there's some Tupperware containers for cases. And technically, it's a Raspberry Pi 4 at the top, and it's STM32. Microcontroller for all the website and you can just connect via URL and then you have a video conference. It's probably better and more proprietary things you can do. And the commands get sent by QTT. Well, to just make it move around. Hello, Yi.
Hi.
Can the robot go to the internet and say hello to the internet?
Again, it's just the first prototype, needs more work. Any questions?
So the commands for the joystick go over the internet as well, or they go directly to the robot?
Well, the interface is with the web page,
Maybe.
and the web page then JavaScript that sends to an MQTT server just be anywhere. This goes to the internet. That's why I have to steal it to my phone at the moment.
So the robot connects to the internet and you connect to the internet.
Yes. And it's no, it goes through firewalls. So I don't have to open any firewalls or anything. Connects to the Jitsi server, and it connects to the public MQTT server for the command. That's it.
So do you see this obviously a separate website useful? It's a bit like Microsoft Teams.
Yeah, I've just put it on my homepage here. It's just a simple interface for the JavaScript to relay the command. So and the JavaScript has some interface for this Xbox, but you don't need an Xbox. You can just go, for example, here, if I click backward, I can connect it through this, but that's a bit awkward. Again, I have to work on that. It's too fast, too slow. And yeah, but in the future, maybe I can bring this to a meetup here, and if you can't make it in, there's another COVID.
Yeah, very
Also, then, it's a bit better than just having a static screen. You can interact, you can move it around, you can point it somewhere. Another thing I haven't mentioned, I put a little laser pointer up here. I switched it off. So you can press a button and then you can point at things to the robot. Yeah, I put a resistor that made it really weak. It's a laser pointer. Yeah, no artificial intelligence in that one. There are probably put line following into automatically to certain places.
How far away are you really from the $10,000 budget? You have to tell me.
Electronics, but I don't know much about mechanics. There's some problems with the motors. The first motors, they were too fast. So as soon as you put a little obstacle there, it wouldn't go any further. So I had to get higher gears. It took another 3 weeks from China. And stronger gears, so that works better. But yeah, there's a lot of solution going on here. First, I tried an ESP32 camera here without the Pi, but with the Pi you have just more options. Next thing I want to try is the way it connects to the internet at the moment is Wi-Fi through the Raspberry Pi here. But you could put a 4G dongle in here, then it would be completely independent of how it connects to the phone. So you put it anywhere out of the street or so. And yeah, there are many ways you could modify this. Another thing is, we've used 50 megabytes so far bandwidth. Also, there's some LiPo batteries down there. I have a current sensor connected to that, so it measures the voltage and the current. You can see it here. Use 2.65 watt hours. On these batteries, 3 times 3 is 85 the standard LiPo batteries, and it runs about 2 hours on that. Yeah. Any other questions?
Do you use ROS?
Sorry?
Do you use ROS?
No, there's no. It's not ROS. It's just a pure Raspberry Pi operating system, and I've
The
modified.
Raspberry Pi is like fancy Ubuntu or something like that,
Sorry?
right? So it runs Linux. Or...
It runs Linux.
Right.
It's standard Raspberry and Linux, and I put a startup script there that connects connects to the web browser.
This is going to
Yeah, this connects to the MQTT server. And one thing I haven't shown here, bandwidth. I mean, that's why I put the screen there. It's always good to see a friendly face. So the robot moves around and it can see you on the other side as well for two-way communication. Yeah, and again, there's lots of things I have to improve. Also, this camera mount here is ubiquity. Another thing I'm thinking about is to put two cameras there, maybe with stereo vision, and then you put it in some goggles, two screens. Again, it depends on how much time I have and where I want to go with it. It's just a project out of interest so far. I don't know if I commercialize that or you want to buy camera.
You think you're doing facial detection, right?
Yeah, before you do that.
Yeah.
And
If you prefer, you need more power. You will need to have
there's one interested in your Jetson. I mean, maybe you could put a Jetson in there.
Yeah.
That's,
which means that again more power, so you have to depending on what you want to do, right? Like you mentioned about Rust, so would you suggest that it's worth the effort of installing Rust? Do you think a Raspberry Pi can withstand Rust?
Even out of Linux, yeah. So Raspberry Pi certainly can. I think. Yeah, I mean, it shouldn't be. I think Rust is challenging to learn. Like I'm not just starting with it, so I know it's hard.
Yeah.
But it's worth it because everything uses Rust. It's much easier to, like with the differential driving. Rust has a package for differential driving. You can just give it the input from your encoders. I guess you come with encoders there. On motors.
these are just
Get the feedback from the how much you actually turn.
it has feedback pulse sensors there.
Yeah.
But I wrote that myself, so this goes to STM32. It's just a simple microcontroller that sits down here. And I wrote that myself. That's why it's not so good. Have to improve it a bit. It just drives the motors. And but then again, ROS is robot operating system, real-time operating system. If I put the control mechanism motors down there, then I don't need ROS up here. So this does video processing. Yeah.
But the main challenge is really, I think that you really try to adapt to whatever you find. It's not like you select it in advance, use that contents from the job.
No, it's just brainstorming, it's just creating and experimenting. And, like this was really wobbly before, so I put these two struts there and experimenting what worked. First I had just one leg at the end here that was very prone to topple over, so I put two legs at the back. Yeah. Hello.
Yeah, that's what it sounds.
Okay.
That's really cool.
What's the next feature that you'd like to implement to it?
Probably the 4G stick that we can just put it outside anywhere. I mean, robot vacuum cleaners, they usually have a docking station. The moment I have to change the battery there, charge it, maybe there's something where it can just fly up to and charge itself.
Yeah.
Many things. Let's see how I go. It has this off switch here, which is working at the moment. Never mind. What other robots are there?
What other robot of that style?
Bring your robot today.
Oh yeah. I mean, you can see some of my robots. You get some questions here. I mean, I didn't read them because they were there, but it's a kit. You can see the node there, which is the most sophisticated in the bunch. Unfortunately, they cannot demonstrate it because it's got from its proprietary battery. So people want to test familiar now is Robocup, which is the international competition for robotics, using soccer as a game, which has been, first Robocup started about over 20 years ago. And that's making soccer robots. So it can do that thing. It can play soccer, obviously, it can fall, it can get back by itself. And this one is not RC, it's a real robot. It's got one processor, and actuator and a lot of sensors. But more approachable for the other robot at the back. That's mostly for people who are interested to experiment. But I'm sure they have got, which I think has a lot of potential, is this one, which is by Lego. It's called Mindstorm. So when you say Lego, it means that you can reassemble it. This is one of the configuration. It comes with a simple sonic sensor to detect proximity of objects. There are the sensors that you can buy part of the kit. The main part of this is this box there. This is what it is. That you can program. Because as Lego is educational, you can just use some graphic style computing, or I think you can also use Java and other languages to program it. After that, you have a series of actuators. So the wheel can turn. Actually, I could probably turn it on, and this one is demonstrable. I need to charge the battery. I've got a working battery. You got another actuator there. So this one doesn't do much. It turns stuff. So it's meant to be a fighting robots if you want, but so but your imagination what you want to do. There are a lot of examples. Might some super popular. It comes from MIT in partnership with Lego. That's E3, is the latest version, unless they've improved it already. The demonstration. So if you got something to detect, let's make sure it doesn't fall. Yeah. That's it. It's a very short demonstration there. Thank you. The other one, which is installed over here, is MakeBlock. It's very popular. And so this is good in a kit. If you want to learn a little bit about building a robot, you just have the parts and fun with trying to screw them, trying to maybe a bit fast sometimes, and how you put all the cabling. So that's one of the fun parts of robotics. It assembling things that works and also
Is that programmable?
Yeah, that's programmable as well. It's very simple. So this one is really simple because it only uses an Arduino. So it's obviously limited in terms of the size of the program that you can load into it. But you can actually do a lot of things. And I discovered that at the Powerhouse Museum, where I'm a volunteer. We have an experiment where we have a table with a line. So this one has 3 sensors. At the bottom, it's got here some color sensors, an ultrasonic sensor. It's got a light detector as well. But those things are reliable, so you can make it follow a line. And with the ultrasonic, you can make it detect objects. And you can explain how autonomous driving works and the challenge of doing it. So even only with this, that's good for, I would say, 12-year-olds, but also for adults, depending on what you want to do. It's fairly sturdy as well. You get people kicking them, making them how long they last. I mean, even so often you replace the parts, it's solid. And that's like this one. And our variation, I think about a year ago also, we had a company that did implementation at our meetup called Acura, and they are based in St. Leonard's, if you remember, and they also do very similar. I mean, you swear there's a blueprint somewhere. It's green instead of being blue. If you look at it, you think, okay, what's the real difference? And they organized a competition, an international competition between schools 2 years ago, which also passed through Sydney, with a lot of various teams and various challenges, including some basic image recognition. It was very impressive. This was a teacher with a group of students, and you can imagine the teacher has limited time, so that's a good preparation package. And the team that won was a team made of all women, girl, 15 years old, we're beating all the team of boys, so we're the only one. There were, I think, 2 years mixed participants. But yeah, that's 2 examples of robots I do today. That's it. Good. I mean, you got you brought something?
Oh, no. No, that's perfect.
Don't want to put on the spot. Anybody has a robot at home that you're playing with?
We've got a rocket.
Yeah, there's a rocket. Yeah. That's a rocket because we're moving the. So this all started with getting rocket kit by hand. And the obvious question to ask is, how high is it going? Which is quite hard to work out. So I started off with using PVC microbit and environment sensor. Is to measure altitude, you want to get the pressure, because the air pressure goes down as you go up. There's formulas to work it out. As long as you know starting pressure on the ground, you can work out the difference and get a good idea of how high you are. I got fairly far with the microbit, but it's using Python, and on the microbit 1, the memory is incredibly limited. So if you just get a string that's a bit too long, then it doesn't like it. Yeah, I seem to have a touch of death this weekend because my phone just killed itself on Thursday. I actually got my son's one, which I've half broken, and now I don't know how this works. Otherwise, maybe you can explain what it does and the point of it. Yeah, so inside here, there's a Raspberry Pi 0W. And it's running an access point, so I can connect to Raspberry Pi and its tablet. And there's also an MQTT server running on Pi. So sending data wirelessly to this one is just, this is running just canned data. Data logging the altitude and time to the CSV file. Also running, trying to run a video as well, although last time died, that's spectacular. We report the altitude, the max altitude, reset everything, turn on and off the camera, and this parachute. So when we, as we go up, we run out gravity and we do a parachute up. And to stop us then listening, because keep going on, straight to the ground, we need a recovery system. The usual one is parachute. So we can detect the maximum altitude. Just after that, we release parachute in a small servo. And hopefully it comes out in a safe state. There is also, so when we get the record button, it starts monitoring that. And as it goes up, parachute hopefully drifts down here. Although sometimes it doesn't work, what is the main issue? That the physics or more the packaging of the parachute that doesn't usually the packaging, yeah. So you can quite think about there are other ways to have helicopters to bring it down.
I've actually been experimenting lately with cheap foam glider that attached to the rockets. So there's shoots off and then just Velcro together, separating it until it slowly comes down. The next stage is getting a camera on it. And that's one of the reasons I've been using it from zero, because it's got a view, so you can get much better proper playing view. So I have actually at home that's got video accelerators and the pressure sensor. I don't think it's got a magnetic. Then I'll be able to inspire by quite a few people on the internet to do it cost effectively. So you have most of them are simple PID frames. So the idea is you have controlled reach access, 3D printer, and have, it doesn't work with water rockets. You have to have a pyro one because you want to sort of slow continuous thrust as you go up. And then it just keeps it stable, which means you don't need any fins. It's just on a cloud with SpaceX ones. I'm not sure I'm going to ever get to that. If you have a look on the internet, there's a product that's phone. It's quite no, it's hardly know. I just wanted the camera as well. And the next thing is probably to get. I've got when it landed in the car, shot the camera off. So the next thing I want to get it recording and streaming at the same time. And you might even be able to stream on YouTube or something. So it was a car for about 15 minutes. You don't need long, you only get about 2 minutes of flights. But it can be sitting around the hotel whilst I'm trying to work. So I've got a very small so yeah, one of the hardest problems was learning how to be extra stuff, working out the use converts like to it probably could be hard because it's all just take the time. It's very cool. Probably a good thing my phone died because it's a lot easier to see a demonstration of it. Stack is a bit limited as well, so there's possibilities of building my own dashboards. It's free scale. For the gyro data, actually have on the alternatives. Although most of the time you're not looking into it to landing. And there is a website, well, a Facebook page I've been logging. High audience on Facebook.
If anybody wants to refer this kind of link, feel free to email us on the meetup.
Spell that for PIHIGH. Rockets. There's a load of other random stuff posted there as well, but there's some pictures and videos. There is a video, the main one, where you can overlay telemetry onto the video, which is quite fun to play around with. Yeah, my background's mostly software, so it's quite fun playing around with hardware.